I'm Peter Smith from the University of Southampton, and this presentation is submission number 72 and is titled Extending the Integrated Modelling of European Migration. This is joint work with colleagues of mine at the university, Georgios, Aristotelous and Jakub Bijak. It is being undertaken as part of Work Package 6 of the Quantifying Migration Scenarios for Better Policy project, QuantMic for short, which has received funding from the European Union's Horizon 2020 Research and Innovation Programme. So here is a brief outline of my presentation. I'm going to begin with some background on why accurate estimates of migration flows are needed and why the reported flows are not sufficient. I will then present the modelling framework before providing some preliminary results and finishing with some conclusions. So, in many countries, migration patterns are the key determinants of population change. While deaths and births remain relatively stable over time, migration patterns can fluctuate greatly. And so in order to get good estimates of the population sizes at a particular time, the migration flows in and out of a particular country are required. For example, whether to build hospitals or to close schools or to fit housing requires accurate estimates of the number of people residing in a particular area or a particular country. And often we require this information for particular ages. And again, migration patterns often vary by age and sex. So accurate estimates of place-to-place migration flows are essential for these sorts of policies. However, there are many difficulties inherent in estimating migration flows between countries. For example, countries may use different definitions of migration. Most countries now use the United Nations 12-month duration of stay definition. That is, a long-term migrant is a person who moves to a country other than that of his or her usual residence for a period of at least a year, that is 12 months, so that the country of destination effectively becomes his or her new country of residence. However, this is not always the case, and some countries report or have in the past reported flows using different durations to define a migrant. Also, different countries use different data collection techniques. For example, some countries, such as the UK, use a survey, where other countries have population registers. So the challenge is to harmonise these different measures of migration to obtain coherent estimates of migration flow. So perhaps the following selection of data will help illustrate the points. So this is the sort of data we have. We have data from the sending and receiving country. So it comes in the form of what's called a double entry matrix. So for example, if we're looking at the flows from Italy to Spain, then Italy, the sending country, may provide a report, and Spain, the receiving country, may provide a report. So in principle, each flow can be reported by the receiving or sending country, and these will not necessarily agree. So here we can see, when we look at Italy, Italy reports in 2009 sending 4,479 migrants to Spain, where Spain reports receiving over 10,500 migrants from Italy. So quite a large discrepancy. This discrepancy can be explained by the fact that Italy tends to underestimate or undercount their emigrants. And this is typical, that countries are more interested in get more reliable estimates of the receiving, the number of migrants coming into the country, than leaving. We also see that some countries, for example, Germany and Poland, don't report any data. So Germany, looking here, sending is not reporting any data, any emigration figures to these countries, and here it's not reporting receiving any immigration from these countries. And similarly, Poland. So sometimes, for example, here we get the report that what are we saying here, that we only get one report. So we only get the report from Italy, and here we get no reports because neither Poland nor Germany report figures on migration flows. Another example here is where we see a considerable difference between, again, similar to the Italy-Spain example, we see a considerable difference between Slovakia's reporting of sending only 62 migrants to Italy, whereas Italy reports receiving over 1,000 emigrants from Slovakia. And that's because of the definitional definition. Slovakia is using what's called a permanent definition for a migrant. So they will only count a migrant record a migrant in their if the migrant intends never to leave the destination. So if they're emigrating from Slovakia, they are counted as an emigrant if they have no intention of returning to Slovakia, and they're counted as an immigrant into Slovakia if they have an intention of never leaving Slovakia. So this number clearly is much lower than this number because these people have to be going to be permanent residents of their with no intended leaving from their country, their destination country. So the aim of the project is to complete the to correct for the differences in definitions, to harmonize the figures to some agreed single figure for flows where we have 2 reported flows, and to estimate the flows where there are no reported flows. And to do this, we're using a Bayesian hierarchical model. So our aim, to summarize, is to produce coherent tables of flows between the 32 European Union and European Free Trade Association countries, the EU EFTA countries, which is quite a large part of Europe, and I may just call it Europe, but not all countries in Europe are actually in this, in the EU or EFTA. And we're going to do this from 2009 to 2019. And we want, because we're trying to provide estimates of these flows, we know there's going to be some uncertainties in these measurements. We're going to use and extend a model previously developed for similar flows from a period up to 2008, the Integrated Modeling of European Migration IMEM project. And that, as I said, uses a hierarchical Bayesian model, and you can find more information about that model in Raymer et al. 2013 and Wisniewski et al. 2013 or 2016. The key here is that we're going to adopt the United Nations definition. So, for example, we want to use the 12-month definition. We also want to, as I'll say in a moment, ensure that we use the correct who is counted as a migrant, the same way as the United Nations do. But we're going to handle these data problems. So as we said, sometimes we have no data for a particular flow. And for that, we're going to use a migration model, which relates migration flows to economic, demographic, and geographical explanatory variables. To handle the other inconsistencies in the data, such as the duration of stay, we're going to use a measurement model. So, for example, we're going to try and adjust the measurements so that they correspond to the correct duration of stay. We're also going to correct for failure in coverage. So some countries don't include certain subpopulations in their reported flows, such as refugees or students, where the United Nations definition does. So we want to have a correction, again, to adjust for the failure to cover the subpopulations. Some countries, as I mentioned, undercount emigrants and immigrants, and this is based on the sorts of data collection methods, and we've reviewed the data and the metadata about the data collection methods, and we've classified the flows or the countries into countries that are excellent, so they have no or very little undercount, countries that have low undercount, so they're relatively good, but not as good as the excellent countries and those that have high undercount, which is they're likely to miss the largest number of migrants. We also similarly have reviewed the data and metadata on the data collection systems and classified those into excellent, which corresponds to countries that use excellent registers to record migration, good, which corresponds to other countries that use other good registers, and to low, which we include countries that use less reliable registers or surveys. So perhaps to give you a little better idea of the model, here is a graphical representation of the model. So we have the migration model. So we assume that the true unobserved flows follow a migration model where we include covariates or drivers of migration. So for example, this model will include the population of the receiving and sending country, the trade between the receiving and sending country, the relative wealth using gross national income of the various countries, whether or not they share, or the extent that their languages are similar, whether or not they share a border, whether or not the receiving country permits access of the sending country's citizens to the labour markets. We also include some information about the stocks in the receiving and sending country related to the flows. So this is a model that, based on a set of covariates, can predict or explain the true migration flows. However, we do have some observed data. We have the flows reported by the sending country, which we believe follow a Poisson distribution with a mean who is determined by the true flows, but are perturbed due to differences in the definition of the reported flow. So the true flows will be perturbed because, for example, the country is using a different durational definition, permanent rather than 12-month, or is perhaps covering not all the subpopulations that are included in the new UN definition. They may be perturbed because of the undercount. So if there is undercount, then the reported flows will be lower than the true observed flows, and there will be some variability introduced by the accuracy of the data collection method if it's a register or a survey. And as we saw, we can have two reports. So we can have the true flows determining the reports sent by the sending country, perturbed by the definitions used in the sending country, the accuracy of the data collection in the sending country, and the undercount of the sending country. We also have sometimes the reported flows by the receiving country with the definition, the accuracy, and the undercount that they have. So that's the model. So now to give you an idea, look at some results. So here I'm going to present some selected flows from over time, from 2009 to 2019. For example, this first example is from Spain to Italy. And when both countries here record the data, so if we have reported data from both countries, we will see the sending country with an I, because we often think of sending from country I to receiving J. So this is the reported flows reported by Spain that went to Italy over time. Here we have the Italy's reported receiving in blue. So this is what they reported receiving. Again, you can see a discrepancy between what are meant to be reports of the same flows. The green line with the M's is the migration model median. So that's the prediction from using just the covariates to predict the migration model. And the black lines are the posterior, or provide information about the posterior distribution of the true flows, the solid line being the posterior median, and the dashed lines being the posterior lower and upper 10 percentiles. So what do we see here? Well, Italy is a high undercount country, so we are seeing a correction. So the figures are being corrected upwards by the model to come up with the median of the posterior median of the flows. The Spain is a low undercount country, so there is some uplift to the posterior medians to account for the undercount also in Spain. Both countries have assumed to be accurate. Therefore, the way the model works, if we have accurate reported data, then the trend in the posterior means will tend to follow the reported data rather than the migration model. The posterior medians can be thought of as the posterior distribution can be thought of as a weighted combination of information from the sending country, the receiving country, and the migration model, where the weights depend on the precision or accuracy of the models and the collected data. So what we're seeing here is that because the data is relatively or being categorized as accurate from Italy, the posterior median of the flows is following that trend. It goes up when the Italian data went up, and it goes down when the Italian data go down. Our second example is from Spain to the UK. So we still have both countries reporting the data. So the Spanish data, the sending country in red, and the receiving country in blue, the UK. Both countries have been classified as having relatively low undercount. So the model, the median and the posterior median, is relatively close, but again, there is an adjustment to allow for the underreporting. Because the UK is a survey, it's deemed to have low accuracy, so much more weight is given to Spain, which has a good accuracy, is a good register. So what is determining the trend here is mainly the reported flows from Spain. So you can see that the black line tends to follow after adjusting for the undercount, the reported red line from Spain. Now, if we looked at a country where the flow is from Germany to Italy, we see that only one country reports the data, which is Italy, and it has relatively large undercount. So what we're seeing here is the shift, but the shift here, because Italy is deemed to have relatively accurate, so although it's undercounting, it's going to be consistently undercounting. We believe that the actual trend should follow the Italian data and not the migration model. Whereas if we move to Germany to Italy, where we now have reported data from an inaccurate country, which is the UK, we believe that we should give much more weight to the migration model. You can see that the UK data does slightly pull the posterior medians away from the migration model medians, but not much. If neither country reports the data, then clearly we have we have to use the migration model, and we also have the predictions will be equal to the median of the migration model. And we will get more uncertainty. I haven't specifically mentioned the uncertainty as I've gone along because it's difficult to compare due to different axes of the number of migrants, but the general rule, as you might expect, is the more data and the more accurate data you have, the less uncertainty there is. However, we can, for a particular particular year, compare the posterior densities for a selected flows. So here the posterior densities for the 5 selected flows that I've discussed above. So here, where we have accurate data from both countries, we have a relatively little uncertainty. So Spain to Italy, where we have no data from either country, Poland to Germany, as you might expect, we have a huge amounts of uncertainty. Where we have some data, the uncertainty is somewhere between the two extremes. And we see that, interestingly, when you compare Spain and to UK and Germany to Italy, that the uncertainty is relatively similar. So Germany had no data to an accurate data, and Spain had accurate data, and UK had some data. So the addition of an inaccurate data source doesn't add much more in reducing the uncertainty than having no data, going from no data Germany to a survey data from the UK. But you do see that if you do have some survey data, you do get some reduction in the uncertainty compared to having no data. So to conclude, we've extended the IMEM model to data for 2009 to 2019. So we have now produced harmonized probabilistic estimates for different European motion growing flows. We're using this Bayesian hierarchical model, so it's providing a natural way of integrating different sources. We have combined a measurement model, which corrects for the inconsistencies in the observed data or reported data flows, and a structural model, which helps us to impute missing flows, and we have coherent measures of uncertainty. Just a few words on some further work. This model has a very relatively simple time effect in it at the moment. So there is a single time effect for each year that's the same across all countries on all flows. So we're considering whether we might want to have some sort of flow specific time effect, perhaps a random slope for the time effect. This model uses expert opinion to help us classify the country's reporting systems, but the IMEM model actually used expert opinion from a Delphi survey to specify the prior distributions for some of the parameters, and we have conducted a Delphi survey for more recently, so we have some expert opinion that we could include as priors, and that's another way of we might take this model or modify this model. Clearly, policymakers are interested in flows to and from the rest of the world into the European EU EFTA countries, so we want to extend this model to include flows from the rest of the world in and out. There is particular interest in how these what are called third country nationals, not from the EU EFTA countries, move from one country to the other countries in the EU EFTA region. So we would like to break down the flows. So for each flow between two EU EFTA countries, we know whether they are EU EFTA nationals or third country nationals. And that will be useful for policy making and to understand the way migrants move through Europe. We also, again, it's interesting for both for policy and understanding, want to break these flows down by age and sex. So if you would like to get some further information about the IMEM project, which gives details of the model that we are extending here in the work I've talked about today, here are some references. If you want to learn a bit more about the QuantVic Work Package 6, which is undertaking the work I've reported today, including details of the survey that we did on the expert opinion and the how we assess the accuracy and coverage of the various data sources, then there are 2 working papers or deliverables listed here.